Today we will start with about the industrial robotics. Industrial robotics is um, one of the best subject at this moment to understand the robotics. So in this topic, I will discuss about a few of the robot control mechanism, but all are in the very basic. So who do not have any knowledge about industrial robotics, they also can start this course without any hesitation. This course is definitely hosted online, as well as it can be available through our live classes. So about this course, let's have the discussion topic today. So today I will first I will introduce you what is the robot and how it works, and then I will put some classification and configuration basic and how the robot motion control, though it looks like everything in one slide, but trust me, it is just a simple part of the courses. So let's go to the introduction part. So if you want to study anything, first you need to know what you are studying about, and at this moment you are studying about a robot. So what is industrial robot? Industrial robot has so many definitions. Among them, the British Association definition is famous. So what is the basic definition? So industrial robot is a programmable device that designed to both manipulate part tools and specially manufacturing tools with variable program muscle. So in other words, if I rephrase it, it looks like that you need to do the programming to control the robot path, and that specific part will be for manufacturing or any other performances like welding or some other part, capturing part. This is the work of the robot. And that robot, if you see the down, there is a robot picture given below, and this picture itself is showing that this is a KUKA robot, which is specially used in Hyundai and Honda automobile industries. And this robot has one cabinet over here, and this cabinet is it has tech pendant. Tech pendant is basically where we control the robot as a robot engineer or a mechanical engineer or a computer science engineer, and whatever the movement we will give over here, that will come to the robot arm, and robot arm will move accordingly. So what is the robot arm? Robot arm basically the hand part of the robot. So if we say the human arm is basically, if human is a robot, then human arm is a robot arm. But in order to work with the robot, there is a few parts. I will definitely come in a little lecture about the lower arm, shoulder axis, body, waist, base, that I will come in later on. But at this moment you need to know about what is the robot law. There is a few laws about robotics. That laws does not mean that you need to know the whole laws of the scenario, but there is a three basic law like Newton's law. So first law, robot may not injure human being or through inaction allow a human being to come to harm. So in first law it is saying the robot cannot harm to the human being. So robot cannot harm basically a human, or in other sense it cannot allow human to harm to the robot. So there is a two-way truth. In the second law, robot must obey the order given it by human being where such order would conflict with the first law. So robot need to follow the human instruction in any manner until and unless that is conflicting with the first law. So the second law is basically depending on the first law, and third law is depending on both of them. You can read it out. So first we read the law, then I will explain it. So the robot must protect its own existence as long as such protection does not conflict with the first or second law. So in other sentence you can say the robot always try to protect his area and his existence because it's a machine, and that's made for. But there is a condition that it should not conflict with first and second law. So if I take an example, suppose a robot is working in a automobile industry, and there is an instruction given over there as per the second law. Instruction by the human need to be followed. Instruction given over there, the robot need to rotate with radius of 25 centimeter. So just range 25 centimeter in a big like that, and suppose there is a human person, I can see an operator, you can see that operator is centimeter radius, In that case, robot will not follow the human instruction. The reason behind it, the first law is saying the robot may not injure a human being or through inaction. So basically, robot cannot harm a human being. So, and in this case, second law is stated it should not conflict with the first law. But in this scenario, the first law is conflicted by the second law. And in the third case, if we want to, when robot is working, if we want to stop the robot by hand, so in this case scenario, robot does not allow a human being to stop the robot, but robot will stop itself, because if robot continue turned on, if someone try to put the hand behind, then it can be harmful for the human. So third law is also based on first and second law. So these three laws basically are interlinked. So you need to know this first in order to understand or in order to work with the robot. So this is a brief introduction about the robot. Introduction of the robot cannot be finished in one class. That might take more than 7 to 8 hours of introduction. Let's go to the next part of the theory, which is the classification and configuration of the robot. This is very basic part of the robot, which is the classification. So how we classify the robot? We can classify it in various types, right? So like number of axes, number of by the control type, or a mechanical structure. Our main aim cannot be the axis, because 3, 4, 5, 8, 9, 10, 11 axes can be have in any robot, which doesn't matter to us. Control type is the one of the main type, playback point to point, or a trajectory operated, or is adaptive robots, or steady operated robot. We will definitely discuss about the adaptive robot and steady operated in some days. So just leave it at this moment. Steady operated is very interesting robot though in my hand. It's used for telemetry surgery, telesurgery in industrial robot. That I will come up later on, don't worry about it too much. So the mechanical structure, which is our main point of view at this moment, the mechanical structure has few types, including the SCADA. SCADA is selective component assembly robot, which is really a interesting part of the robot. Is a type of robot basically. Articulate robots, parallel robots. Parallel robots also used in the dental industry, which is very much useful. I know a few professors who are working on this, really interesting. Spherical robots, cylindrical robots, and one of this one, the mechanical structure. What is the difference between these mechanical structure? In one word, if you want to describe what is the difference between these mechanical structure, the main difference between this mechanical structure is the degrees of freedom, which is a mechanical term. I will explain it later on. But in views, by the eyes, you can say the shape is different for all of the cases. So like that. So robot configuration. Now I will come little bit of explanatory mode of the last slide. So which is basically what is the robot configuration? The first configuration I am taking, as I told you, mechanical configuration is very important to me at this moment. So cylindrical. So what is a cylindrical robot? Cylindrical robot itself has a large work areas, a large operating volumes, usually employed in a radial workstation, ideally for loading and unloading applications. So a cylindrical robot, you can imagine cylindrical robot can be like this way. So it's a kind of like cylinder. Let me try to draw it in a moment. I'm not sure how I can draw it. Hopefully I can. Let me see. Okay, so for cylindrical robot, that basically like this. Do you know the cylinder? The same thing it should be. So this is a kind of like a robot will be there. So that's the reason it should be radial workstation. Radial means it's a circular workstation. So like this, like the picture over here, a robot is a cylindrical robot is working in a manufacturing area where machining center to be done, quadrilateral to be done, milling to be done, and lathe to be operated. Cartesian. Cartesian is well known as rectangular. Definitely is a kind of like this rectangular surface. Work envelope is basically where the robot works. That's the work envelope. Application in assembly operation. machine to loading, palletization, injection, molding operation, etc. So while we can do it like a parallel. Palletization means like we will just there is a stack like that, and I need to put like this. So that's the palletization. Polar robot is basically the one of the earliest configurations, sometimes referred to as spherical robot. It basically has a like a sphere thing like this. If I am right now, so over here joined like this, so this is spherical. So the movement of this one like it like this. So main application is palletization. Spot welding is very important, and joint arm horizontal axis articulate robot is basically this one is basically a human arm. You can call it human arm. So human arm is a horizontal axis joint arm. So like it has fusion. It is also very useful for sport welding adhesive application that is specially used in automobile manufacturing industry. SCADA is a, as I told you earlier, safety compliance assembly robot arm, which is basically servo motor in each joint. I will try to show you a SCADA robot in some lectures definitely. So that is basically direction. The SCADA robot is it has the servo motor for each joint, and this joint move accordingly. But moving this joint is a control mechanism. I will just explain in the next slide. So robot motion control. Robot has too many motions. Obvious reason there is a. The easiest to do is P2P. P2P we used to do when we have we know the which point need to go the robot, and we know the each and every part. We just do the point-to-point configuration, and that can be that easily modified by the operator, which is very easy basically. But that's not the always point of us, because every time we cannot define the point. Suppose there is a large industry and you have 10,000 robots and you cannot do each of point to point. So instead we need to use programming, which is called the control path or continuous path. So continuous path has two parts, which is joint interpolation and the Cartesian interpolation. Joint interpolation, Cartesian interpolation, I will definitely comes to that, but in order to understand joint and Cartesian interpolation, you need to know how many kinematics is there. So what is a robot kinematics? Robot kinematics is the mathematics behind the robot control. That basically in one word. And it has two types of kinematics. Forward kinematics and inverse kinematics. There is a basic difference between forward and inverse, which is very important question for each of the industrial robot papers. So just keynote over here. So forward kinematics and the inverse kinematics is basically the difference between the input and outputs and complexity, you can say. The first thing, the joint angles for the forward, we know the joint angles and we will calculate the end effector position. In inverse, we know the end effector position, we need to calculate the joint angle to reach that position. So the two methods, I will definitely explain in the next slide in detail view, but not the mathematical part of that. But I will show you the equations. But don't worry, don't afraid about that. I will won't go beyond the equation. You just need to, I will just tell you, but later on I will come with a video where I will describe the forward and inverse, and we always describe this in classroom, in our classrooms. Easy for multiple, the forward kinematics is very easy for multiple degrees of freedom, where complex is very difficult to do, which is very standard need to be done. Now, this part, this is the thing where I want to explain a bit for 5 minutes. Let's think this is a robot, 2-arm robots basically, 2-arm. So one arm, so if I mark it, this is one first arm and this is the second arm. So these two. You can see there is the measurement of the arm is L1 and L2. This is basically the arm length. We definitely know from the robot manual or anywhere we can get it easily. We need to measure it definitely. P is the end effector position. This is the end effector. Theta 1, theta 2 is the angle of the arm based on their position. X and Y I just put in global axis. That's very simple. So for the forward kinematics thing, we know this theta 1 and theta 2, we need to calculate this x and y. So in this case, what we are finding this x and y. I will definitely explain this one. It's just a trigonometry, just a simple trigonometry that you did in your 12th standard, 11th standard maybe. So, or college standard, preschool standard basically in your term. So if you know the theta 1 and theta 2, we need to calculate the px, which is very easy task to do. But in the other hand, it has inverse kinematics. Inverse kinematic scenario, we know px and y. We know this for inverse kinematics. In this case, we are calculating these two. In this case, we are calculating these two. Okay, so basically we know this one, we know these two, x and y, because we know for inverse kinematics ik, we know about this, and we need to calculate theta 1 and theta 2. This is a simplified formula given over here. That's not too simple though. I will definitely explain on the next classes. So this is the two basic difference. That's the reason from calculating from xy to theta 1 and theta 2 is pretty different. If there is inverse kinematics problem, then you might have different answer for each one because of the tan theta and tan alpha 1 assumption. I will definitely, what is the tan theta? Definitely, I will explain it in the later parts. So don't worry about it. Just leave it. Just know about the inverse kinematics. So these two are the Mason motion control or major kinematics need to know to control the robot. It's very interesting. Now, if you know the robot, you know the robot law, you know how to control the robot, but what you will control? You need to control something. And when you are controlling, you need some feedback from the robot. And how do you get the feedback? Sensor. Just like, suppose I will try to itching. What do you find? You will say, ow. It's because your nervous system is getting a sensor that your skin is getting pinched by something. So that's the reason you say ow and you remove your hand. So your hand is your end effector. For robot, hand is the end effector. Sensor for you, sensor is the skin. For robot, sensor is few type of sensor is there. I will discuss over here. So first is the end effector. So end effector consists of finger and a drive mechanism, like finger and your drive mechanism. This drive mechanism also, if there is a mechanism that requires a power source, and the power source is the three types: pneumatic, hydraulic, and electrical. And third is interface between a gripper and robot. That means when to extract or when to put the power. So these two you need to know. In the next one, this one I won't go too much about it. I will just putting through. Just I will pull through what you need to do. The gripper design, you need to do the gripper design. You need to consider some parts that also detail in the inertia moment. Why inertia moment is important? Suppose a robot pick up a part and it is rotating. So obvious there is a force to take out that part from the robot. So in order to keep that part in stand, how much force is required by the motor? So that's the inertia moment you need to know. So in order to control the robot, we have different type of gripper. In this gripper, so we specifically used the linkage mechanism. Linkage is basically a part where we go through the movement of the stops will give you the movement of the ropes will give you the motion. So that's the part we use in the linkage. In gear and rack, we move the gear. So you know how the gear works. It's very simple. Screw driven is just a screw will move up and down. Robot will move like horizontal axis. For rope and pulley, we put the motor in the rope, and that contract the rope, and that gives the tension, and that actually control the robot arm movement. So that basically, if I see in a column, I can try to. This is the rope. When we pull the rope in that way, this two will come to that way, and when we put in that way, when you leave the motor, it will come to that. It's as simple as that. It's very simple. Same as this, when I put the screw that way, it will come to closer, like this and this. Okay, and same like this, then it will move out. Same like that way, similar. And cam actuated is basically the cam profile. You all are mechanical engineers know about the cam profile. What is that? This is the cam. So when it cam, and this is the followers. So when this cam is rotate, this followers having a motion of up and down, and due to the up and down, we can have the robot motion synchronously, which is very, very useful. Robot sensor, there's a few type of sensors that include the force sensor, light sensor, proximity sensors, and temperature sensors. Don't trust me. These are the very basic sensors I provide here. Robot has so many sensors over there. I will definitely have a session with the robot sensor itself. In the force and torque sensor, the strain gauge is one of the example, or a servo motor can be the example for motor current measurement. Light sensor is basically very useful when the robot is a humanoid robot. Proximity sensor is very much required for without a physical contact, robot can know what is in front of him, so he can stop and he can actually lose some control over there. And the same with the temperature sensor. Now I'm coming to the application. Now this is the almost the end part of our today's discussion. Where the robot can be applied? Robot can be applied everywhere. You need to think a robot is applied even in your dream. So that's the application of the robot. Wherever you can think, you can apply the robot. Few industry I mentioned over here: manufacturing, assembly, medical, and airline. Now, except of this, it also has customer care executive position and so many things. If you see this robot very carefully, this is the FANUC robot, which is very known one-arm robot, which is used for the semiconductor assembly, like motherboard assembly. Can you imagine the human hand is assembly? This one is my major interest on this. This is a cruiser, one of my best friend. It has sensor. This is a cruiser sensor. You know, this is a cruiser sensor. So cruiser can hug you. This is also a cruiser sensor, and this is cruiser face. I will definitely not it is implemented for the customer service in Netherlands airport. Very useful. First point of contact. This one is the latest one, which is in India. You can find in Bangalore Robotics. Is Mitra and Maitra, and they both are introduced in first time in the COVID situation, and they are the frontline audience. I will definitely have a lecture on this, how they are operated and how they are working, what the working principle. Not more than half an hour, but I will have an explanation. So these are the major application. So even if you see the recent design model launched in India, it has 2,000 robots working. So Maruti, Suzuki, Hyundai, they all worldwide trying to prefer the robot solution instead of human, which is basically a good challenge for us. Now the challenge for the human: did they survive? And that question is for you. Do you think the robot can lose the human jobs? Let's think. We will discuss it one day, and that will be the live session for you. So the question for today is: do robot help to increase the unemployment in a country? So that is a controversial question. I will give it to you on the first class of the industrial robotics. Let's have That's it for today. Thank you. If you have any questions, let me know. So by this one, I will end this session for today. Let's meet on some other day. Till then, bye. Bye for now. Bye bye.